Euler phi function. Phi function. Okay, so it is denoted by phi of n, and it has its own application in number theory. So first we'll define what is phi function, then we'll consider important properties of phi function, and then few questions we'll try to solve. So what is this phi function? Phi function, it is, suppose if n is a positive integer, if n is a positive integer, then phi of n, it represents the the number of positive integer which are less than n and co-prime to n, that is GCD of, suppose that number it is x and n, it should be 1. Okay, so number of positive integer which is co-prime to n. Okay, for example, if you want to take, suppose phi of 5, what will be the value? So less than 5, what are the numbers you have? 1, 2, 3, 4. These are the numbers you have. And if you consider the GCD of 1 and 5, it is 1. GCD of 2 and 5, again 1. GCD of 3 and 5, 1. GCD of 4 and 5, this is again 1. So altogether how many numbers you have? 4 numbers. So phi of 5 will be 4. Okay, similarly if you are interested, you can find phi of 10. You will see 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the numbers which are less than 10, positive numbers or positive integer less than 10. And out of these numbers, if you consider GCD of 1 and 10, GCD of 3 and 10, GCD of 7 and 10, GCD of 9 and 10, this will be 1. So what will be the phi of 10 value? Phi of 10 will be 4. So total 4 numbers you have for which you will get this GCD as 1, and they are less than 10 as well. So this is our phi function. Now related to this, here we have basic or fundamental formulas for this phi function formulas. So in this way you can find the phi function value for a certain number. If the number is small, then you can do this manual treatment and you can find this. But if suppose that number it is a large, then this formula it is going to help you. Suppose if n is a composite number, if n is a composite number, so it can be expressed as p1 power a1, p2 power a2, up to pn power suppose an. Okay, then this phi function, phi of n, it is n times 1 by p1, 1 minus 1 by p2, 1 minus 1 by pn. This is our first formula. All these formulas has their own proof. So if you are interested, you can go through the proofs. And if n is a composite number, if n is a prime number, previously it was composite, now if n is a prime number, then phi of n, it is directly n minus 1. So you can check this phi of 5. 5 itself it is a prime number, so you are getting 4. So 4 is nothing but 5 minus 1. Okay, and here phi of 10, 10 itself it is a composite number, so this 10 can be written as 10 2 into 5. 2 means p1 power 1 a1, p2 power a2 means 1 here. So phi of 10 is 10 as per this formula, 1 by 2, 1 minus 1 by 5. So what you have? 10 half, here you have 4 by 5. So what you have? Ultimately 4. So already you got this 4. So if the number it is a large number, then one can easily apply this formula, and if it is a prime number, then this formula. These two are important formulas. Now the next thing related to this topic, it is Fermat's little theorem. Fermat's little theorem and Fermat's little theorem, very important. And you write down this: if n is a positive integer, if n is a positive integer and greater than 1, and if a is any integer such that GCD of a and n it is 1. Okay, then what you have, a power phi of n it is congruent to 1 mod n. Okay, and in particular in remark you can write, if n is prime, what you have, phi of n it becomes n minus 1. So this formula it becomes a power n minus 1 congruent to 1 mod n. That is, in other words, you can say n divides a power n minus 1 minus 1. Very important formula for number theory. And all these formulas, this formula and previous 5 functions formula, these have, for example, you want to find 2 power 2019, or last digit of 7 power 7 power 7, okay, or 3 power 419, what will be last 2 digits, okay. So last 2 digits. So in that case these formulas are very relevant. Okay, so we'll solve this type of question in subsequent parts. Now for the time being you should keep all this formula in your mind.